All right. So we got properties of special parallelograms. Okay. Now, when we're talking about special parallelograms, you can probably already guess. What are some special parallelograms? Rectangles. Squares. Rhombuses. You got it. So we're going to talk about some of those. And we'll skip the bell work. All right. We got a couple fill-ins here. The rhombus diagonals theorem and the rhombus opposite angles theorem. These are special theorems for rhombuses. Okay, there's some fill in the blanks, so watch out for those. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So it already told us it's a parallelogram. It's a rhombus if and only if its, there you go, diagonals are perpendicular. See the line? Diagonals are perpendicular. And then the second blank down there, I think, is your AC is perpendicular to BD. AC, which is one diagonal, perpendicular to BD, the other diagonal. Is a rhombus a parallelogram?
Yes.
No. Always. Let's try it again. Is a rhombus a parallelogram? Always. Now that concept there is important, and as you guys kind of finish writing this stuff, is a student always is every student in the world always a Lake student? No. But is a Lake student always a student? Yeah. Right? You're a specific student that goes to Lake. Right? A rhombus is always a parallelogram. Correct? Is a parallelogram always a rhombus? No. All right. Next one. Still a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So notice the word bisect, but it's different than the parallelogram. The property of a parallelogram. This one says the diagonals bisect opposite angles. Do you see the diagonals cutting angle A in half and angle C in half, and then this diagonal cutting angle D in half and angle B in half? Yes? Now, let's stack on some information. What else can you tell me about these diagonals? Because it is a parallelogram, the diagonals also bisect each other. You don't need to write that in here. You don't need to write that in. I'm just stacking information. What else? It's a rhombus. We just learned that the diagonals are always perpendicular. That's 90. You get a 90. You get a 90. You get a 90. The diagonals are, so in a rhombus, the diagonals are perpendicular and they bisect opposite angles. They also bisect each other because it inherited that property from the parallelogram. Make sense? We're good with rhombuses. What's another special parallelogram? A rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. Congruent. This one gets used all the time. Okay. Now, please don't be that student that says, "Yeah, what you're about to say, I get it. You use it, but I'm never going to use it. This is just stupid." Okay. Please try to become a little more mature, and instead of saying, "I'm never going to use that," try to think, maybe I could use that in this way someday, or maybe I could understand that it's at least helpful in that way. All right. When you're laying things out outside, all right? Whether it's a building or a plot of land, or maybe you're going to put in a garden someday, all right? Just because, let's say you have a section of fence over here and over here. Maybe you just buy a section of fence at the local hardware store, all right? And the section of fence you buy is 20 feet long. And this section of fence is 20 feet long, okay? This section of fence is 16 feet long, and this section of fence is 16 feet long. You just put them up, attach them, and cross your fingers and hope for the best, okay? Question, is it a rectangle? I hear yes. Pretend that fits together. Or else rabbits are going to get it. Okay. Is it a rectangle? Who votes yes? Let's vote. Who votes yes? Who votes no? Who votes maybe? Okay. Listen for it. What do I have right now? Two pairs of opposite sides that are congruent. Right now it is a parallelogram. Do you agree? Right now it's a parallelogram. To exaggerate it, this could be the same garden. Do you agree? That could be the same garden with the same information. Yeah? So here's what you do. If you're setting up a garden, okay, and you have 20, 20, 16, and 16, you measure with a tape measure. You measure each diagonal. Okay? Let's say this diagonal is longer than this diagonal. Not a rectangle. Just a parallelogram. So what do? You kind of bring this fence over and bring this fence over because you knew that was the longer diagonal. And then what? Do it until the diagonals are congruent. And if the diagonals are congruent, now it's a rectangle. You see what you do there? I'm being honest. This is actually used when plotting out sections of whether it's land or whatever. Okay. Like I told you guys before, I do woodworking, and I made all the drawers in our kitchen, like all the drawers. And every time I went to put some drawers together, I cut them all the same. These are the same length, these are the same length. But when I went to glue them up, I didn't want parallelograms. Okay, so I would measure the diagonals. Okay, and actually, if they were I'm making a bunch of the same size, I would already just have sticks pre-cut that I knew the diagonal length and just put it there, and then I'd actually have to adjust the clamps to get it to be a rectangle because there's very, very little margin of error when you go to put them in. So rectangles have what kind of diagonals? Congruent diagonals. Rectangles. Do rhombuses have congruent diagonals? No. Okay. No. Their diagonals are perpendicular and they bisect opposite angles. Okay. Is a rectangle a parallelogram? Yes. Is every parallelogram a rectangle? No. Okay. It is a special parallelogram. So here we go. I think this is going to help you. This helps me. I don't care whether you like Venn diagrams or not. Do you guys understand Venn diagrams? Yeah. Okay. So here's the world of quadrilaterals. This outer rectangle, it's not really a rectangle. It's just an area. Don't worry about the shape. It's an area. This is the world of four-sided polygons. Within this world of four-sided polygons, there are parallelograms. Can you give me an example of a four-sided polygon that is out in this region out here? Trapezoid, perfect. Yeah, it doesn't have two sets of parallel sides, does it? One set of parallel sides. Good. How about kites? Have you learned about kites yet?
No.
The geometric shape of kite? No. It's actually the same as what you fly. Okay. Kites are not parallelograms. That is not a parallelogram. It's a four-sided polygon. Not a parallelogram. All right, then we have parallelograms. Inside of parallelograms, we have rectangles. And we have rhombuses. Now, because we know how Venn diagrams work, the rectangle region is this whole region right here. The rhombus region is this whole region right here. And I bet it wouldn't take too much thinking to guess what is the shape where they overlap. Squares. So to continue my analogy, are you ready? In the world of students, there are like students. In the world of like students, there are students that are in the ever so popular Ultimate Frisbee Club. Ever so popular. Trending. All right. In the world of Lake High School, who does Ultimate Frisbee Club?
Me and Jared.
Jared, let's use Jared as an example. Jared, what other activities or sports are you in?
Baseball.
Baseball. Okay. Ready? World of students. Lake High School. Ultimate Frisbee Club. Baseball. Jared. Right?
Jared's running Sunday class.
Jared, you're special. You're special.
Special.
You are a student. You are a Lake student. You're in the Ultimate Frisbee Club, which that alone is impressive. Okay? And you play baseball. We could go on. I mean, this Venn diagram is just it's holding him back. Okay. All right. So you get my analogy. Right? Is Jared in the Ultimate Frisbee Club? Yes. Is he in baseball? Yes. Is he in Lake High School? Yes. And is he just a general student? Yeah. Okay. That's almost offensive, though. Just to call you a student. All right. So when you think things through, do you agree if it's going to be a square, it needs to be a parallelogram that's both a rectangle and a rhombus? You get that? So guess what? When you go through, if you were to actually stop and think about how many properties does this square have? Well, here we go. You ready? How many properties does a parallelogram have? Two sets of opposite sides congruent. Two sets of opposite angles congruent. One angle. Actually, just in general, consecutive angles are supplementary, and the diagonals bisect each other. So a parallelogram has four properties. Do you agree? Let's keep going. What's the rectangle property? Diagonals are congruent. We're up to, I guess I gotta use that figure. Up to 5. Don't laugh at me, Jackson. Get out of here. How about a rhombus? Rhombus has, its diagonals are perpendicular, and its diagonals bisect opposite angles. A square has 7 properties. 4 that it inherited from being a parallelogram. 1 it inherited from being a rectangle, and then 2 more for being a rhombus. Do you get that? Awesome. Well, hello, Levi.
Yeah.
All right, for any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. All right, so wait a minute. Let's read the directions. For any rhombus, QRST. 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 Q congruent to S. Sometimes, always, or never true. They didn't give us the option or never, but you might get that option sometimes. Who votes sometimes true? Who votes always true? Some people just aren't voting. Do your civic duty, people. Gotta vote. All right. Opposite angles being congruent was a property of a parallelogram. Is a rhombus always a parallelogram? So this is always true. All right, next one. Talk amongst yourselves. You guys can go on guided notes, Levi.
Yes,
Get
please.
here on time. You get guided notes.
Not that I
Go, bro.
slept so well late on that night.
I'm just trying to take this.
Oh,
They could be different by how that'd be a red. Is that what that is?
Oh, yeah.
It's only always or something. Unless you can.
Because like this one is like
That's something.
so I guess there's
all right. Here we go. Q is congruent to R. That should bother you at first, okay? Because consecutive angles are always, so it's a parallelogram. Consecutive angles are always supplementary, right? But that's not what they said. They said these angles are congruent. Is there ever a scenario where consecutive angles can be both, they have to be supplementary, it's a parallelogram, right? And we're told it's a rhombus, correct? So is it ever a possibility that consecutive angles can be both supplementary, which they have to be, and congruent? If the rhombus is a, yeah, back up a bit first. Rectangle too, right? Yeah, you're right. If this is a rectangle, now why did I make them back up? Because what's the property of, oh, we didn't write that down yet. I have it on your paper. I didn't put that diagram on mine. You see up at the top, key ideas. I forgot to put that image into my notes. You see a rectangle is a parallelogram with 4 right angles, which you already knew that. So here we go. If these angles are both 90, then they would be supplementary, which they have to be. It's a parallelogram. And congruent. Do you agree? So, but is that always true? No, just sometimes, right? And for those who struggle with that, here's what you need to think about, guys. I need you to listen, okay? Hey, guys, when you guys talk, people can't hear around you. All right. The reason I guess the way you need to think through this if you struggle with this concept is, okay, I know it's a rhombus. Does a rhombus always have consecutive angles that are congruent? No, it actually rarely does, right? So it can't be always true. Do you agree? A rhombus doesn't always have consecutive angles congruent. But if it's a special rhombus, if it's also a rectangle, then it can have consecutive angles, both supplementary and congruent. So that's not an always situation. It's a sometimes situation. Good on that? All right. All right. Find the measures of the numbered angles in rhombus ABCD. So first of all, is this a parallelogram? Yes, because it's a rhombus, it is a parallelogram. So as soon as I see that, I'm thinking, okay, 38, yes? Alternate interior. But it's a rhombus. These angles at D and B have been bisected, meaning this is also 38. Angle 1 is 38 degrees. Do you guys all agree? Because rhombus bisects opposite angles. How am I going to find big angle C?
$180 minus
Good.
divided by 2.
Yeah. What's big angle B? It takes 2 38s to make big angle B.
76.
So what's big angle C? 180 minus 76. 104 degrees. You guys all agree? Consecutive angles are supplementary. What's angle 4?
52.
52 degrees. What's angle 2?
52.
52 degrees. What's angle 3? Come on, 90. Diagonals are perpendicular in a rhombus. We're told it's a rhombus. Diagonals are perpendicular, 90 degrees. Do you see how to work your way around the picture using the properties? But you have to know the properties. You have to know the properties. Now they call them theorems, that's fine. But I call them properties. They're the properties of rhombuses. Questions on that problem? We need to keep moving. All right, you're told this is a rhombus. Okay. What's the easy part here? Opposite sides are going to be congruent. So we're going to set 3b plus 4 equal to 13b minus 9. Subtract 3b from both sides. Add 9. And divide by 10. I'm getting 1.3. Do you notice I ignored what it asked me first? Do you notice that? I'll tell you why in a minute. All right, what's 3 times 1.3? 0.9 plus 4? 7.9. This is a rhombus. All 4 sides are congruent. Do you know that property of a rhombus? Yes, no, maybe. Okay. Did I put that one on the top? I really need to add this to the notes. I totally forgot. A rhombus is a parallelogram with 4 congruent sides. Now, let's talk about that. When we wrote these theorems out, why wasn't that here? Because that's the definition of a rhombus, okay? A parallelogram with 4 congruent sides. All right? So definition. And what's our rectangle definition? Parallelogram with 490 degree angles. Now, could they tell us less than that? They could say a parallelogram with 1 right angle, couldn't they? If it's a parallelogram that has at least 1 right angle, think about it. Parallelogram, if it has 1 right angle, what's the opposite angle? 90. What's the consecutive angle? 90. Do you see how just a parallelogram with 1 right angle makes all 4 90 degrees? Yeah? Okay. So as we go through this, it's a rhombus. This side's 7.9. And they're asking us for side TV. Don't say, but it's not labeled. It's a rhombus. All 4 sides are, congruent, makes it 7.9. Now the tricky one, the angles. They're asking us for VTZ. That's this angle right here. And don't say 5a minus 5. Okay? That's the expression we want an actual angle measured. Man, I don't know any other angles in the picture. Or do I?
14.
We're going to have to solve for a first, aren't we? What's 14a plus 20 equal to?
90.
90. We'll solve for a. We plug it in up here, and this angle right here is going to be the same. See it? Let's do it. Some of you are looking confused. Well, that's just your normal face. The diagonals in a rhombus are always perpendicular. We can set that angle equal to 90. Divide by 14. So 5. But I want to plug 5 in up here. 5 times 5 minus 5. What's 25 minus 5? 20 degrees. And because a rhombus's diagonals bisect those opposite angles, this angle down here is also 20 degrees. So VTZ is 20 degrees. What's big angle T? 40. What's big angle V? Supplementary to 40. 140. What's big angle W? 40. What's big angle X? 140. Okay. I don't go off of looks very often. Like when I look at a picture, we've warned you about that. Okay. But I would agree, if it looks like a rhombus, you can kind of use the eyeball test sometimes. And I'm not saying go off of does it look like a 140 degree angle, but if this looks like a 140 degree angle, this doesn't, right? Don't make a mistake like that where you say these are the same. They just, for most rhombuses, they're just not going to be. All right. Let me see where we are right now. We only have 5 more minutes left. I want to address this one. I'm not going to actually solve this one. Tell me the property about a rectangle's diagonals. A rectangle's diagonals are always congruent. They gave us QS. They gave us RT. What are we going to do with those diagonals? Set them equal. Very good. Okay. All right. We'll come back to that one. Hopefully we'll have some time tomorrow to finish this up. This is one of the challenging problems from this lesson. All right. We have A is negative 2, 6, B is 6, 8, 4, 0, and negative 4, negative 2. You guys have this one graphed?
No.
All right. How are we going to decide if it's, well, first of all, is it a parallelogram? We're told it's a parallelogram. Okay. How are we going to decide if it's a rectangle? If there's 490 degree angles, or if we could show somehow that the diagonals are congruent. This one doesn't look like it, but we still have to show it. Okay. How would you find out if AC and BD are the same length on a graph? Slope doesn't find length. Distance formula finds length. So when we go to do the rectangle, is it a rectangle? Are the diagonals congruent? Okay, we're gonna have to do that. We'll try to do this one tomorrow. Okay. How about a rhombus? I know some properties of a rhombus. One of them has to do with the diagonals bisecting opposite angles. That's not realistic here because I don't know how to find the angles on this rhombus, possibly. The other one has to do with the diagonals being perpendicular. Could I show these diagonals are perpendicular or not? Yeah, if they're, so diagonals, slopes are what? Opposite reciprocals. Like 3/2 and -2/3. How are we going to show that it's a square? If it will have all the properties, but what things do we need to check to see if it's a square? Well, the side lengths being congruent, it will have to be a rhombus if its diagonals are opposite reciprocals. So we don't need to check for 4 congruent sides, because if it passes the rhombus test, if its diagonals were perpendicular, automatically it's a rhombus that has 4 congruent sides. Well, if it passed the rectangle test of diagonals being congruent, it will have 4 right angles. If it passes both. If it passes both, then it's a square. If it's a rectangle and a rhombus, then it's a square. So good news. Check these 2 things, and if it passes both, then it's a square. If it just passes one of them, then it's just the one that it passed. Does that make sense? All right, we'll practice this tomorrow. There may be one I need to check in the homework if I have time. Hang tight. One second.
Surprisingly.
No, I'm talking to my right hand. No, I'm talking to 14.
All right, listen up real quick. 57 is the only one on the homework that has to do with the graphing that I just showed you. Okay, I want you to graph it. I want you to check to see if the lengths of the diagonals are the same, rectangle, and if the diagonals are perpendicular, slopes. Okay, and try to do that one, please. All right, the other ones were ones we covered pretty thoroughly.